Good morning, pre-calculus. So continuing in Chapter 5, we're going to look at graphing rational functions, Part 1. So we're going to take what we did in 5.1 with the asymptotes, the vertical asymptotes, and then the horizontal asymptotes, either the end behavior or the slant and oblique asymptote. We're going to add that to the ideas of X intercepts and Y intercepts and maximums and minimums and all that other good stuff, put it all together to sketch graphs of rational functions. So before we get into it, let's kind of look at where we've been, kind of put it all together and talk about all the things that we know, and then we'll look at some sample problems. All right, again, when it comes to a rational function, we know a rational function, some f of x, some p of x over some h of x, and we've seen this a sub n x to the n plus all the way down to a sub 0, b to the m x to the m plus all the other stuff down to b sub 0. And these are the things that a lot of stuff happens in here, but these are the things we're focusing on: lead coefficients, degrees, and the constants. So let's just talk about graphing these things and what characteristics can we tell. What things do we know? When we look at one of these things, what do we know? What can we tell? First, let's talk about the vertical asymptotes. They tend to be one of the most important aspects. They're the domain restrictions. The vertical asymptotes are the zeros of the denominator. When you set the denominator h of x equal to 0. Those are my vertical asymptotes, my domain restrictions, my do not cross lines. Next, the horizontal asymptotes. Well, that's where it depends on the degree. If the degree of the numerator is less than the denominator, then I've got the line y equals 0. If the degree of the numerator is the same as the degree of the denominator, then I have the line y equals lead coefficient over lead coefficient. And then finally, if n is greater than, if the degree of the numerator is bigger than the degree of the denominator, then we have to do the long division, and y equals the q of x, the quotient, ignoring the remainder, and that is my slant or oblique asymptote. So these are the things we've done in the last few lessons, but what else do we know? There's other things that we know other than these asymptotes. So let's continue this. What about X intercepts? Well, we know where the X intercepts are. The X intercepts are the zeros of the numerator. So just like we find the vertical asymptotes, the domain restrictions, by looking at the zeros of the denominator, we can find the x-intercepts by looking at the zeros of the numerator. The y-intercept. The y-intercept is going to be, when you plug in 0 for x, everything's going to disappear except for the constants. So the y-intercept is going to be 0, comma, a sub 0 over b sub 0. The constant over the constant. That's going to be my y-intercept here. And then the end behavior, as x's increase without bound or y or decreases without bound, that's really going to be my horizontal asymptotes here. So what I'd like to do is I'd like to take a look at several examples, specifically dealing with each one of these. This one is kind of the pain in the neck one. These ones are not so bad. So in the first part of today's lesson, we're going to look at an example where the degree of the numerator is less than the denominator, and where the degree of the numerator is equal to the denominator. And we're going to add x and y intercepts and draw sketches and look at these things. All right, here we go. So in the first case, let's take a look at the following function. F of x equals x minus 1 over x squared minus x minus 6. And as soon as we look at this, just a whole bunch of stuff kind of just jumps out at you, and we're thinking about all of these things. Let's kind of break it down in order. So the first thing I want to look at is vertical asymptotes. Those are going to be the zeros of my denominator, my domain restrictions, what makes the bottom equal 0. So x squared minus x minus 6, set it equal to 0. This factors nicely into x minus 3, x plus 2 equals 0, set each factor equal to 0, x equals 3, x equals negative 2. There are my vertical asymptotes. How about the horizontal asymptote? I was just thinking, well, what order do we want to do these things in? And it really doesn't matter. I would always do the vertical asymptotes first because they kind of trump everything else. Domain restrictions, even if I get a 0 in the numerator, that would represent a hole in my graph. But those are one of the most important things. As I look at my horizontal asymptote, and it's all about the degree of the numerator and the denominator. Now notice here, the degree of the numerator is less than the degree of the denominator. So I have the case where n is less than m, therefore y equals 0 is my horizontal asymptote. This thing's going to get closer and closer to 0 as x's increase without bound, and closer to 0 as x's decrease without bound. All right, now let's take a look at the X intercepts. The X intercepts are the zeros of my numerator. The numerator is x minus 1, so x equals 1. Now don't circle that because the line x equals 1 isn't anything here. This is the X intercept. In other words, when x is 1, y is 0. That's an X intercept. Don't confuse it with the vertical asymptotes here. And then finally, my y intercept is going to happen when I get zeros in the for x's in the top. I'm going to have negative 1 over negative 6. In other words, when y is 0, lead coefficient over lead coefficient, I'm going to get positive 1/6. So here's all the information. I know my vertical asymptotes, my horizontal asymptotes, my x-intercept, my y-intercept. I know what the end behavior is as x's increase without bound, what the function is doing. So now I want to put all this together and create a sketch of this. We're going to do a sketch and then we'll put it on the calculator to see how close our sketch is. All right, let's see. What were those asymptotes? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 2. All right, so putting all the information on here, what do I know? Well, I know I've got vertical asymptotes at 3. 1, 2, 3. Here's a vertical asymptote. Do not cross line. And x equals negative 2. Here's another one. Do not cross line. My horizontal asymptote is the y-axis. So, and I know that that's my end behavior. I don't know if you can see that very well, but as x is increased without bound, I know it's going to be getting closer and closer this way. What else do I know? I know that my x-intercept is 1, 0 right here, and that's the only x-intercept. It doesn't cross the x-axis anywhere else. That's the only place. And the y-intercept is 0, 1/6. So some number right about there, really close. So some number really close here. All right, so let's see what happens. So I know these points have to be connected. Now, does it jump up and go up here? No, because that's not a repeated. If it was a multiplicity of 2, then it would be a touch and go, but it's not. So these have to be connected. It can't cross that line. The only thing it can do is run down the asymptote. What about over here? Could it come back down and run down? No, because it cannot cross the x-axis again. It doesn't go through here. It's not a hole. So the only thing that it can do is that. That's the only thing it can do. Now on either side of these asymptotes, I don't know what's happening here. It could be down here like this, or it could be up here like that. Remember, it cannot cross that line, and it can't cross the x-axis again. That's the only place it crosses the x-axis. So how do I know if it's up here or if it's down there? Well, I'm going to pick a point and test it. 1, 2, 3, 4. If I plug the number 4 back into the original function, and really all I care about is if it's positive or negative, 4 minus 1 is a positive number. 4 squared, 16, minus 4 minus 10 is going to be a positive number. Positive over positive is a positive number. So it has to be up here in the first quadrant. Can't cross that line, can't cross that line. The only thing it can do is that. What about over here on the other side of this asymptote? Well, it's either going to be up here or down there. Which one is it? Again, I'm going to pick a testing point. So 1, 2, negative 3. If I plug negative 3 in, negative 3 minus 1, negative, I get a negative there. Negative 3 squared, 9, minus a negative 3 plus 3 minus 6. I get a positive number down there. Negative over positive is a negative. It's down here in the third quadrant. And again, this is my function, f of x equals x minus 1 over x squared minus x minus 6. Now let's throw it on the calculator and take a look and see how good we did with this sketch. So I'm opening my y equals, the numerator in parentheses, x minus 1, close parentheses, divided by, open parentheses, x squared minus x minus 6, close parentheses. Go to a standard viewing window, zoom 6, and there it is, just as we expected. And I know it's hard to look, you can't really see any detail up here on the overhead, but take a look on your calculator. Look how, as x's increase without bound, as the x's increase without bound, the function approaches 0. And over here, similarly, as the x's decrease without bound, the function approaches 0. This is end behavior. This is my end behavior. That's what's happening. The end behavior happens as x's increase without bound or decrease without bound. All the stuff that's happening in here is called the intermediate behavior. The intermediate behavior includes things like my X intercepts, my Y intercepts, my asymptotes, maximums and minimums, turning points, all that other good stuff. Look at the, one of the things that I want to point out too is, look at the end behavior asymptote. This is my asymptote here. And look how the function actually crosses the horizontal asymptote in the intermediate behavior, in the middle here. It's allowed to do that, but it can't do it anywhere else over here. It's an X intercept here, but it's a limit. As I increase without bound or decrease without bound, the function gets closer and closer and closer to 0 without ever crossing it. So here we have our first example where the degree of the numerator was less than the degree of the denominator. Let's take a look at another example where it's going to be the same. So in my next example, we're going to have f of x equals 6x squared minus 15x plus 6 over 4x squared minus 10x. And straight away we can see that we've got a second degree over a second degree, so we've got the case where they're going to be the same. But let's rip this thing apart. Let's look at all the different possibilities that are going on here. So the first thing I want to look at is, or look for, are my vertical asymptotes. The vertical asymptotes happen at the zeros of my denominator. So I'm going to set the denominator equal to 0 and solve. 4x squared minus 10x equals 0. I can factor 2x out of the top, and I'm left with 2x minus 5 equals 0. Set each factor equal to 0 and solve. 2x minus 5 equals 0. 2x equals 5. X equals 5 halves. Here are my vertical asymptotes. At x equals 0, I've got a vertical asymptote. And again, at x equals 2.5, I've got a vertical asymptote. Now let's take a look at the horizontal asymptotes. And the case that I've got here is the numerator, the degree of the numerator is equal to the degree of the denominator. That tells me that my end behavior asymptote is going to be y equals lead coefficient over lead coefficient, 6 over 4, which of course can be reduced to y equals 3 halves. So there is my end behavior asymptote, my horizontal asymptote. Next I want to explore the x-intercepts and the y-intercepts. The x-intercepts occur at the zeros of my numerator. So as I take a look at, set the numerator, 6x squared minus 15x minus 6 equal to 0, or plus 6. 16x squared minus 15x plus 6 equal to 0. I notice I can factor a 3 out of that, make the numbers a little bit easier to deal with. 2x squared minus 5x plus 2 equals 0. Divide by 3, divide by 3, divide by 3, divide by 3. So now I've got this. Does this factor? It is going to factor nicely. 2x minus 1 and x minus 2. 2 times 2 is 4. I can split the middle term into a negative 4 and a negative 1 and factor. Set each factor equal to 0. 2x minus 1 equals 0. Add 1, divide by 2. X equals 1/2. X minus 2 equals 0. X equals 2. Now be careful. Don't circle these. These would be vertical lines. And this has nothing to do with vertical lines. These are my x-intercepts. In other words, when x is 1/2, y is 0. And when x is 2, y is 0. These are intercepts. And then finally, I want to look at my y-intercept. The y-intercept happens at the constant over the constant. So the y-intercept, if I take a look at this, it's going to be y equals, let me rewrite the function up here because it's something kind of interesting that happens. 6x squared minus 15x plus 6 over 4x squared minus 10x. Now, if I let the constant over constant, I'm going to get y equals, the constant in the top is a 6, the constant in the bottom is a 0. Well, what does this mean? This is undefined. In other words, there is no y-intercept. And some of you probably figured that out when you saw the vertical asymptote of x equals 0. The vertical asymptote at x equals 0, that is the y-axis. And so that's an asymptote. It never crosses the y-axis. It has 2 x-intercepts, it has 2 vertical asymptotes, and a horizontal asymptote. All right, so let's put all of this together and sketch a graph, and then we'll put it on our calculator to see how close we are. All right, so what do we know? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2. That should be enough here. And first thing I'm going to do is I'm going to put in my vertical asymptotes at the line x equals 0, which is the y-axis. No y-intercepts on this thing. And at 5/2. 5/2 is 2.5. 5/2 is going to be right about here. There's my vertical asymptotes. My horizontal asymptote was 3/2, 1.5, which is right about here-ish. And I had x-intercepts at 1/2. I have an x-intercept right here. And I have another x-intercept at 2, right there. Now, believe it or not, we've got enough information where we can sketch this thing without thinking about anything. So, what happens between the asymptotes? Well, it has to cross these two lines. Now, remember, it could cross the horizontal asymptote. Could it do this? Yes, it could, because that's intermediate behavior. At the end behavior, it's going to get closer and closer to these. So, or it could look like this. So it's either going to be like this or it's going to be like that. How am I going to decide? Well, if I pick 1, plug the number 1 in and test the number 1, I'm going to get 6 minus 15 plus 6, which is a positive number. And then 4 or 6 minus 15 plus 6 is a negative number, rather. And 4 minus 10 is a negative number. Negative over negative is positive. So at 1, it's positive. It's up here somewhere. So if it's up here somewhere, the only things that it could be doing is this and that. We know it doesn't touch and go because it doesn't have a multiplicity here. How high does this go? Does it go up and through the x? I don't know. But it definitely turns and comes back down here. Now, what about on this side of the asymptote here? Could it be down here? No. Why not? Because it would have to cross the x-axis, and it doesn't. These are the only places that it crosses the x-axis. So it cannot be down here. It has to be up there. Has to run up the asymptote here and run along the horizontal asymptote there. Similarly over here. Could it be down here? No, because it can't cross the x-axis. It has to be up here. And this is f of x equals 6x squared minus 15x plus 6 over 4x squared minus 10x. Let's put it on the calculator and see how well we did. So on the calculator, go to my y equals, and I'm going to open parentheses, 6x squared minus 15x plus 6, close parentheses, divided by, open parentheses, 4x squared minus 10x, close parentheses. Go to a standard viewing window. And here it is. There it is, running up the axis, running down the axis. I'm going to zoom in a little bit here. I'm going to go from, I want to focus in. I want to look at this a little bit better, so I'm going to change my window. The x's, I'm going to go from -5 to +5. And then the y's, I'll zoom in on that a little bit. I'm going to go from, let's say, -5 to, well, we'll leave it at 10. I want to see the stuff that's up there. And then graph it there, so kind of emphasizing the window. There it is, running up the axis, running down. And of course we know the equation of this line. I could graph this line in there. If I went to y2, I know that that's 3/2, 3 divided by 2, 1.5. And if I graph that, there's my horizontal asymptote. And you can see it getting closer and closer and closer to the horizontal asymptote. So again, just a rough sketch by kind of pulling this thing apart, looking at the asymptotes, the intercepts, looking at the intermediate behavior, at the end behavior. As x's increase without bound, f of x approaches 3/2. As x decreases without bound, f of x approaches 3/2. As I approach 2.5 from the positive side, from the right, it's going to positive infinity. From the left, from the negative side, it's going to negative infinity. And these are the vertical asymptotes that do not cross lines. All right, so that's the first two cases. The next one is when the degree of the numerator is bigger than the degree of the denominator, and kind of something awkward happens. But before we look at that, I want to look at another situation. So go ahead and pause the video here. Take a look at the homework. You can probably do most of 5.2 right now. There's just one more thing that I want to talk about in the next video. So spend about 10 minutes, 15 minutes looking at the homework, and then play the second part of the video.